Let's continue with our next example. We're going to solve 5x minus 8 is equal to negative 2x plus 6. So one step that I always like to redo or to do first is rewrite the equation in my own writing. It's just a habit that I've gotten into. And I think it's good because it helps me identify what's going on and gives me pause time to let me know what might be a path forward. So on the left-hand side, I might want to isolate my variable. On the right-hand side of my equation, I might try to isolate my constant. Does it matter which one we move in a balanced strategy? Not really. So perhaps what I'm going to do is I'm going to eliminate negative 2x to the right-hand side of my equation. My original equation is 5x minus 8 is equal to negative 2x plus 6. So what I'm going to do to eliminate 2x from the right-hand side is I'm going to add 2x. But if I add 2x to the left-hand side, I'm going to add 2x to the right-hand side. So really, this is just 5x plus 2x minus 8 is equal to, and if you notice, negative 2x plus 2x is 0. All I'm left with is 6 on the right-hand side. As I further simplify, 5x plus 2x is 7x. 7x minus 8 is equal to 6. A good thought in algebra is one thought per line. It really does help clean out the work. So far, so good. Now, are my variables isolated to one side? Yes. The variable x is on my left-hand side. Is it isolated? Not really, because we have this negative 8 on the left side. So what I'm going to do is I'm going to add 8 to both sides. And what we have is 7x is equal to, I'm going to add the right-hand side, that's 14. So we're getting pretty close. Now, this is 7x is equal to 14. What I can do is I can divide both sides by 7. And when I do that, it's x is equal to 2. Right, move on to the next question. Here we are. 4 plus 3t is equal to 0. Sometimes this confuses people because it's a lot simpler than what we just tackled. But what I'm going to try to do is I'm going to try to isolate the variable on the left-hand side and the constant on the right-hand side. The variable that I have is 3t. The constant is 4. So I'm going to put all the constant on the right-hand side. So 3t. So I'm going to get rid of what I just highlighted in green by subtracting 4 to both sides. Now notice although I didn't write subtract 4 on this side, it was implied. So really, what I'm going to do is, I have 3t is equal to negative 4. What I'm going to do is I'm going to divide both sides by 3. Because 3 times t. All right, this next one is a little bit tough. It's a balanced strategy. And what we do to one side, we have to do to the other side. Now this one is a little bit tough. I'm actually going to solve it 2 different ways. One way you have to be more careful than the other. So what I'm going to do here is I'm just going to simply rewrite my equation. I have 38 over x is equal to 2. Now if you notice, in my denominator I have an x, which gives me some pause and discomfort for sure. Here's what I'm going to do. I get the clever idea that I'm going to multiply both sides. Both sides by what? Well, I'm going to multiply both sides by x. And really, on the left-hand side, I have a common factor of x in the numerator and the denominator. So those x's cancel each other out. So I get 38 is equal to 2x. Now, what's different about this equation, the way I've navigated it, is the variables on the right-hand side this time. So 38 is equal to 2x. What I'm going to do is I'm going to divide both sides by 2. And if I do that, 38 divided by 2 is 19. Did you know 19 is x? And that's the solution that I have. Okay, I promised you that I would solve this a second way. So here's 38 over x is 2. Now I wrote 2 over 1, which is just simply 2. Can you imagine or envision a mathematical process that might make this easier to solve? Sure. You can take the reciprocal of both sides. And since both sides are monomial, it's fairly straightforward. So I have now x over 38 is equal to 1/2. So my next step is I'm going to multiply both sides by 38. The factors of 38 cancel. And on my right-hand side, I have 1/2 times 38, which is the same as 38 divided by 2. And we discovered that's 19.